Okay, page 29. So let's read this problem here. Okay, so we have, as an avid sky watcher, you know that the moon is always half illuminated by the sun, and that how much of the moon that we can see illuminated depends on where it is in its orbit around Earth. For the first month of the year, you watched the moon and kept data for the amount of the moon that was visible in each day. So for the day of the year, we're going to populate that on the x-axis, and then the portion visible of the moon, or the portion of the moon visible, we're going to scale that on the y-axis. Okay, so just to kind of help you with the scaling here, we're going to go by twos. So each of the x values will be, each of the x value increments, sorry, will be going up by 2. So if you guys can fill that out all the way to 60, and then the y values will go up by 0.2. Okay. And after you have done that, then you're just going to try to make your best approximation. I know that, plotting 0.81 or 0.46, the best you can do is to try your best and estimate where those values are. But the idea is that after we plot all those points and we connect the dots, it should resemble either a sine or cosine graph. Okay, and we're going to try to create the equation of that sine or cosine graph based off of what we put on paper. Okay, so spend a few minutes or spend a minute or two doing that, and then we'll go over each of the other parts. Okay, so now we're going to start plotting the points here. So day 1, 0.5. Day 4, 0.81. Okay, you're going to go down the line and plot the points all the way to order pair 59, 0.5. Okay, so your graph should look something like mine here. Okay, give you guys another minute to plot those points. Okay, so after you plot those points, take a look at the graph. What does that look closer to these? Does it look more like a sine or a cosine? So I'm thinking it's more closer to a sine because it starts at the midline and then it goes up to max. Now, obviously, we can always make any sine graph a cosine graph, but it just seems like it's closer to a sine graph. Okay, okay, I have a definition for you guys to copy down here. Sinusoidal functions. So that word comes from sine, and it's basically I'm kind of describing a sine graph. So a sinusoidal function is a smooth curve with a repeating oscillating pattern. So oscillating just means that it swings back and forth. And if you look at your y values, it kind of goes up and down around the midline, right? Swings back and forth on either side of the midline. So if you had to guess, what do you think the length of the period is for the cycle? Yeah, it's around 30 days. Okay, so if I start at 1, I see that my full pattern is going to be completed right around 30. Okay, so we can see that full cycle there. We know it's not going to go all the way to 60 or 59 because that looks more like 2 full cycles, right? We have a full cycle from 1 to 30. Now, we're starting at 1, which means that it's not quite 30, right? It's going to be 30 minus 1. Okay, so our period is the time needed to complete a full cycle. We started at 1, we end at 30. If I subtract those two values, I get the period of this particular cycle, which is 29 days. Yes?
So if we started, like, would there be times when we start at 0?
It depends on the data. So if the data starts at 0, then great, we can just start at 0.
And then you would have to subtract.
Then we'd have to subtract, right? So technically you're subtracting minus 0, which is not going to change, right? Yeah. So we're always just kind of depending on what the data tells us. Yes?
So let's do it.
Right. Right. If it starts at day 2 and goes to 30, then we'll do 30 minus 2. Okay. Okay. Any questions so far? Okay. Next up, do you see a vertical shift? And if you do, where do you think the midline is? 0.5, right? So it looks like that the center of the graph is at 0.5. We're treating it like a sine graph, and sine graph starts at the midline, so it looks like that midline is at 0.5. Okay, good. We can say that the equation of that midline is y equals 0.5. In terms of our A, B, C, and D value, that's lines up with our D value. D value is 0.5. Okay, questions so far? All right, what do you think about the amplitude? What do you think the amplitude is for this curve? 0.5, good. So you know your midline is at 0.5, but then the distance from the midline to the top of the graph is going to be 0.5, right? Okay, so amplitude is 0.5. Amplitude is defined as the distance from the midline to the peak. Okay, let me highlight the midline. Okay, so the 0.5, even though they are repeated, they mean different things, right? The D for 0.5 is because it's 0.5 at the center, and then the amplitude just also happens to be 0.5, but that's actually the distance from the center to the max. Okay, what do you think about phase shift? Is there a phase shift for this sine graph? So sine graph usually starts at 0, right? So we can shift it to which direction? To the right. Well, our sine graph is going to be starting at 0, so the sine graph is going to need to be shifted to the right to make it look like this graph, right? So your C value would be what? Or how would you write it as -1? Good, -1. -1 would be shifted. Okay. So from that information, can we write the equation of the sine graph? Okay. So go ahead and try that. You're going to put it in this form. Identify your A, B, C, and D value. A lot of it we found. But, something we do need to find is the B value, right? So we have a formula for that. We have our period. From our period, we can find our B value. This is a sine graph that we're targeting. So our period formula is going to be 2 pi over B. Okay, so try that a moment. See if you're able to put all that together and write out the equation of this sine function that we have above. Okay, what you guys find for your B value? Yeah, you guys get that? 2 pi over 29, okay. Okay, A value is 0.5, we found that from before. D value is 0.5. We found our B value from the period we determined. And then we're shifting it to the right because we know the sine graph normally starts at 0, but we wanted to start at 1, so we're going to make it shift to the right 1 unit. Okay, questions?
What was the B value?
Sorry?
What was the B value?
Okay, the B value is 2 pi over 29 because our period is 29 days, and we just work in to our 2 pi over B formula. Yes?
Can you use theta instead of x?
That's right. You can use any variable you want. You can use theta or x. Sometimes I may even use t because t in terms of days, so you're free to use whichever variable you want to use. Okay, any questions?
Yeah,
Yeah, I'll spend another minute on this page. But for those of you who are finished, go ahead and turn to page 30 and read the problem and see if you're able to start gathering some information. Good, all right. Okay, so page 30, problem 2. There are many rides at the amusement park whose movement can be modeled using trig functions. The Ferris wheel is a good example of a periodic movement. As someone is riding this ride, the height of that rider is going to continually kind of repeat itself, right? It's always going to cycle back to the low point and the high point, height off the ground. Okay, so it says you want to ride this Ferris wheel. It has a radius of 95 feet. Let me indicate that. Radius is the distance from the center of the circle to a point on the circle. So any of these distances will be 95 feet, right? Okay. Suspended 20 feet above the ground. So let me indicate that. The wheel rotates at a rate of 2 revolutions every 20 minutes. Okay, let's go to part A here. What is the period of the function that models the movement of the Ferris wheel? How long does it take to complete a full cycle? 10 minutes, right? So 2 revolutions in 20 minutes, so 1 revolution, 10 minutes. Okay, so period, 10 minutes. Okay, what is the midline of this function? So let me draw where the midline is. The average height of the ride. Okay. Midline is the D value, right? What is that value, you think?
What value is the midline?
Midline is the D value. D value. Okay, so where's that height? Good. So we know the 20 is the lowest point of the circle. We add on the radius. So we know that's our midline. There's another 95 up here. Okay, so midline, we can think of the midline is it's the average height during the ride, or average height of the ride. Okay. Everybody good? How we got that 115? Right, 20 plus 95. Okay. We can also call that the D value. Okay, average height during the ride. All right, what about the amplitude? What's the A value? I would say it's 95, right? If our average height is 115, this rider can go as high as 95 feet above 115 or 95 feet below 115. Yeah, so A is 115. Okay, so the amplitude is going to be the max distance from the midline. Okay, it says write the equation of a sinusoidal function, either sine or cosine, but let's see if we can graph this function first. We're going to kind of gather some information about this, about this ride experience. We'll let the x be the time, and we'll let the y be the height. So we'll create some order pairs here. let's just see if we can gather some information about the ride. So let's say we're at time 0. When you're at the beginning of the ride, how high will you be off the ground? Right, we enter the ride here, right? We enter the ride at the lowest point. So time 0, 20 feet. Okay, I'm just going to put this under this graph, the function, but it's just, I want to be able to see this as well, so I'm putting it on a separate sheet here. Okay, let's say we are a quarter of the way through the ride. How long will it pass before I hit this point? So the whole ride is 10 minutes, right? So 2.5. Okay, so 2.5. So that means 2.5 minutes into the ride, how high will we be off the ground? Good, 115, okay. Okay, let's gather some more ordered pairs so that we can graph it. And once we graph it, we'll be able to kind of decide, okay, this is I think we'll have easier time with the cosine function or easier time with the sine function. Okay, now we're halfway through. Halfway through, how long will that be? 5 minutes. Okay, so 5 minutes, how high off the ground? 210, right? 95 plus 95 plus 20. Okay, so now we are 3/4 of the way. How long will it be before we reach this point? Okay, 7.5. And we're back at 115. And finally, 10 minutes, 20. Okay, so spend a few minutes to see if you can graph these order pairs onto graph. So I'm just going to go by 2.5. And I want to go all the way to 210, so I'm going to start at 20, and I'll go by 20. How about that? Okay, so just try your best to plot these order pairs that we gathered. And I think once you have the picture in front of you, we're having an easier time to kind of decide, okay, maybe this is a better fit for a cosine or a sine function. Okay, what does that look like? What do you think would be easier model to use, sine or cosine? Cosine, right? Cosine, usually though, cosine starts at the max, so what adjustment do we have to make with our a value? Negative, right? So it's more like a reflected cosine function, okay? All right, so see if you can fit this into a cosine function that matches this form. Again, you can use any variable you want. In fact, I think I use t, but you can use x, t, or theta. Okay, we said cosine is a better fit. The nice thing about cosine is we don't have to worry about a shift, right? We know our c value, which is b0. Okay, so we can leave c out of it. We just have to figure out our a, b, and d value. You know the period is 10 minutes, so from there, see if you can work your way to finding your b value. We found our a value, we found our d value, so oops, sorry, I messed up here. A is 95, right? 95, sorry, I messed up. Yeah, 95 is distance from center to the max. Okay, so your A with a negative. Okay. Okay, what'd you guys get for your B value? Mm-hmm. Okay, how do we do with this equation? Okay, part 2, determine your height above the ground at 6 minutes. How can we find the height of the ride 6 minutes in?
Was this the bonus, or wasn't like something like this?
Very similar.
Were we supposed to write that equation?
I think the equation was given to you in the problem. I think which is a similar, it was the same picture, but it's a different way of asking a question. Okay, yeah, so how can we find the height? Good, we have an equation that tells us the height at any moment in time. So if I plug 6 into for x, or whatever variable you're using, we should be able to find our height, right? So use our calculator. Make sure that we are in radian mode. So if you go to mode, double check you're in radian, not in degrees. Yeah, so let me show you. You see there's a mode button near the top. Make sure that RAD is highlighted and not DEG. Everybody see that? Yeah. So once you're in radian mode, because anytime we're dealing with radians and trig, we have to make sure that we're in radian mode, otherwise it's going to give us a weird answer. Yeah, you're going to go to mode. And then make sure that RAD is highlighted and not DEG. Okay. If you do second mode, you go back to your home screen. And now you can type in your function and replace x with 6. I think I messed up here. Sorry, I should have put in 6 for x, right? Because we're plugging 6 in for x. So I'm going to say times 6.
Did you just do parentheses? You don't
Yeah.
do brackets?
That's right. Yes, parentheses is good enough. Do you guys see? So round to nearest. Well, I rounded to 192. You guys get 191 point. Okay.
I got 20 because I put X.
Yeah, that's what I did first. We need to put replace x with 6. Okay, so now part B. Suppose the Ferris wheel is now moving faster and it completes a revolution in 5 minutes. How would that change our equation? Yeah, just change the b value, right? Instead of 10 equals 2 pi over b, you'll do 5 equals 2 pi over b. Okay. Guys, after I finish this page, I'll come around and see if you have any questions about your calculator. I can help you with that.
What do you round it to?
I should round it to the nearest height, so I round it to 192. Okay, part C. If the radius of the Ferris wheel remains the same, but the height of the wheel was raised 15 feet higher. So instead of entering the ride at 20 feet above ground, let's say we're entering the height 15 feet higher than that. How will that change our function? What you guys get for C? What would change if the first wheel was raised up? Yeah, the D value would change, right? So instead of plus 115, you'll make it plus 130. Okay. Questions? Okay, your classwork is the next page. I will show the answers after a few minutes. I'll show each part. But if you guys can go ahead and try that and finish that off for the rest of the class. Okay, so I think I should be plenty of time. Okay, does anybody still need this page? So what I did on the next page was the bottom, each increment was 1 month. And then for the vertical component, I went up by tens. Yeah, for the y-axis, I went up by tens.
So we have to start at like 0.
It's up to you. I mean, I went up by 0, but if you just want to do,
Like 40.
that's fine.
I didn't write with A.
I'm sorry? Okay, plot the points and then connect the dots. And then we want to see, is this going to match better, or would it be easier to build this off of a cosine or off of a sine equation? I'm sorry? Yes, that's right. So we're just trying to get through 31, and that will be your classwork. But I'll show you each of the steps. I think we have enough time where I can show you each of the steps.
That is not correct. It is not 78 in August. August is the hottest month in Georgia.
Yeah, you're right. It's not accurate.
Correct.
It'd be nice if it were true. So, guys, for part A, I have the period being 12. So even though we're starting at 1 and ending at 12, we're kind of just assuming that it's going to kind of cycle back from December. So I'm letting that period be 12. Yeah, it's also average. I think it's open for interpretation. I'm going to just have it be 12 so that our numbers will line up a little better here. So I'm just assuming that at the beginning of the year, it's going to be more like December. And also we can kind of have the graph kind of match with our December average temperature. So I'm kind of letting it go to 45 at the beginning, just so that I can feel like it's a full cycle from 45 degrees to 45 degrees. Okay, what's the vertical shift of this model? What's the midline? Yeah, it's around 60, right? Okay. It says K, but I meant for that to be D. And if you can have a dotted line representing your midline, then it's easier to measure your amplitude, right? What's your amplitude? 20, yeah. Midline to the max. Midline to the peak. Okay, what does this graph look closer to being? Does it look closer to being a cosine or a sine? Cosine, right? I see that minimum showing up in January. So if we can just shift it slightly, we can turn it into a cosine graph. Well, actually, cosine would start at the minimum, right? So if we can imagine our cosine graph starting at 0, 40, what shift can we make to make it turn into this graph? -1, yeah. We want to shift it. We want to shift our original cosine graph to the right, 1 unit. Okay. And then from there, see if you can write the equation of your cosine. You know your A value, you know it's reflected. You've just found your B value, and you found your D value as well. Okay. I'm giving you guys 1 more minute to write your equation, and I'll show part E and F. Which one?
E.
Okay.
E, the phase shift.
Yeah, phase shift is going to be 1.
Oh.
But it's going to be -1. Mm-hmm. Okay, check your answer. Sorry?
Why is the phase?
Okay, why is the phase shift 1? So you know that this graph that we have starts at 40, right? But cosine graph, we want the cosine graph is more like this. So if I write the equation without the -1, it's really this purple graph here.
But there's no zeroth month of the year.
Oh, wait.
I'm sorry?
There's no zeroth month of the year. So why couldn't you just create the graph with the first month of the year on the y-axis?
Oh my gosh, I'm putting. Yep. Is that all? That is.
Yeah, that's all. Let me think about that for a moment.
Okay, I want to see what's that.
Well, yeah, but I put the. What did you scribble out?
Oh, no, I was just talking about how this was the original graph, and then that -1 will take the graph and shift it to the right.
I got 40 and I got 60.
You did it wrong.
It's okay. I know that we're not yet. Doesn't have to be exactly 600.
So Morgan, it's not very clear, but I want the cycle to begin and end at 45. So I'm letting this be 40, but I'm kind of shifting it to 45 so that I can feel like I have a full cycle. And then because of that, I am making this my minimum. And that's why I'm shifting it to the right. But I can see where your argument is, because you're saying that the entire January is 40, so it should be at 0. But okay.
I want to make sure I got it right.
But if it starts at 40, then I don't have a full cycle, so that's why.
So